specifically with regards to the advanced metering infrastructure case studies. Okay. And also we will study, the components, integrated components, how the components are arranged in the advanced metering infrastructure, and what will be the methodology adopted nationally and internationally, what type of communication have been employed, and how this particular communication has strengthened the utility hand in determining the the strength of the communication, and also the entire structural thing, with regards to the advanced metering infrastructure as a whole. So today's presentation overview is like as follows. I would like to discuss first, some of the case studies, both national and international, and consumer engagement policy regulations. We would like to study some small regulatory aspects related to the advanced metering infrastructure. I would like to discuss something about the communication technology for the advanced metering infrastructure and some of the case studies there also, and integrated arrangement of AMI. How the arrangement of AMI is integrated into a holistic, simplistic arrangement. Okay, we will see what happens to the whole study when we commence, doing the things on a practical networking system. So a few AMI case studies. One international I have chosen, and two national I have chosen. So we will see first, international case study. This is actually TNB, Malaysia, smart meter, advanced metering infrastructure pilot project. Okay. So here, the pilot project was funded by the Malaysian government, and the implementation of 1000 smart meters in the state of uh, Melaka and Putrajaya. So these two are the main states actually. The project is part of DNB's Smart Grid Initiative activity. You can see here the advanced metering infrastructure. In fact, the components also has been discussed here. Tools for the customers to save energy, DR, demand response, for economic operation, enhanced customer service, enhanced electricity supply reliability, revenue assurance, and efficient business operation. This is how the AMI is surrounded by the case study for this particular project. The implementation stages and progress is as follows. You can see here the meter and network install and network optimization has been started actually. The project starting, meters, communication, and IT hardware. Here, the smart meters and communication and MDMS have been chosen for the operation actually. Okay, as you can see. Phase 1, Phase 2, Phase 3, and Phase 4 are the activities in the pilot stage, wherein the different entities have been followed up. One is the automated billing, the second is the load profile, the third is the main influence on the outage notification and load management. Okay, this is a portion of the DR with which the project has been emulated. In phase 4, the main content of the project was new billing, that is the advanced billing arrangement, that is smart billing they call, and also tamper detection systems and schemes with which the project has to be operated upon. Okay, here the network performance evaluation and meter and network installation optimization have started. And finally, they have gone to what we call larger AMI. This is known as mass rollout program. The mass rollout was followed by initial pilot, and they have ascertained each and every component working. Component in the sense, AMI components, the smart meter is one of the components, communication, head end system, MDMS, all these things have been thoroughly studied. It is not that they have left any stone unturned, because the project is very important at the final stage. In the final stage, there should not be any failure, and redundancy, etc., must be in line with the planning operation. So that is how the project started. So as you can see here, the AMI pilot project system design and services. You can see at the left side the meter with the Zigbee communication. It is integrated into GPRS, RF mesh, PLC, known as the hybrid versions. And it goes to their own WAN system, wide area network, and head end system. This is nothing but the MDAS. Okay. And then it comes to the meter data management system, which is used actually for the billing purposes. And there is a web portal. And then this comes to a bus called ESB. That is nothing but the enterprise service bus. The enterprise service bus consists of the billing, the traditional billing. Here, it is ECIB. That is nothing but, corporate internet banking earlier. So this is earlier actually. This color is earlier. And this color is the new color. That is, the new system they call. In this portal, they have, the billing system, the shutdown notice management system, CMC, customer management, and email SMS system. And also it will have e-services which were earlier available, and they have integrated into the SAP networking system. That is for the ERP process, to make sure that the advanced metering infrastructure fall in line with the traditional technology system. Like, the automated billing, load profiling, okay, non-technical loss detection, supply automation, web portal introduction, billing operation, smart billing, TOU pricing, time of the use, outage notification. This comes actually as a sequential operation. And with regards to this outage notification, it is nothing but outage management portal with which it is possible to get the notification. Okay. And then finally it goes to the DR and the DSM. That is, the demand side management and DR. They are the ultimate actually in the AMI infrastructural management. So this is how, the project took over. And this is how the project has been initiated and made successful. Pilot, they started a pilot actually, the pilot smart meter. First phase rollout was in 2016 at the state of Melika. Here, 300,000 smart meters were installed. In the second phase, 2 million smart meters. And finally, they have gone up to 8.3 in 2021. And the rollout plan is very clear. Number of meters here from 5 lakhs, 1 million, 1.5 million, 2 million, up to 2022, they have completed this activity. And this is an enhanced activity which has taken into account the various failures that has occurred in initial stages. In the pilot scheme, they have detected these failures, and they have integrated those failures into what is they call as the study analysis. And the failures have been converted into opportunity by initiating not only the failed component or failed system, they have called for a new system itself or new component itself, to make sure that this repetition is not there. And they have learned a lesson in the project, and they have incorporated it very successfully. So this is how the whole scheme has started. That is the national project. Next, is the that is the international project. Now next, in Mysore, Karnataka, they have incorporated some smart meters based on the AMI rollout. This is a pilot project which has given a lot of impetus for the company, and a lot of information. Those information have been strengthened to make sure that bulk rollout or mass rollout has to be taken up in accordance with the pilot decisions. So here in Mysore, we have the main study, the key components of advanced metering infrastructure, residential. Here, we have the uh, remote metering reading, remote disconnection, outage detection and management system, tamper detection with disconnection, TOU, time of the use, prepaid, that is the credit metering mode with the over the air, that is, we call OTA, okay? Change provision, OTA in the sense, it is in the cloud actually, okay? Real-time load monitoring, right? Energy auditing, two-way messaging, bidirectional messaging, that is from the consumption and pricing information to the consumer. A net metering philosophy, which we will discuss actually in the evening, afternoon. Meter data acquisition system, this is actually MDAM. So this is how the project has been started and then incorporated at the stages here. As you can see here, RF mesh. So this is the DCU, okay? And then, here we have the GPRS, RF mesh, and then this is a communication system and comes to DCU. And from DCU, it goes to the MDAS to MDMS. So this is how, the project has been started at Mysore. And this is energy accounting, demand side management, okay, and then the DSM and outage monitoring. This is how, the applications have been selected for the project management cell, okay. This is how the project has been initiated. Key benefits envisaged actually. In fact, I am only taking the first important thing because we are concerned about the AMI, but it's a whole project. As such, it's a smart grid project we can call. And in the advanced metering distribution automation system functionality, here, main benefit is the loss reduction and the key index improvement. Okay. This is where, key project improvement actually. Here, main thing is the envisaged benefits is AMI employment for the loss reduction technology. That is what, we have to see in totality. Okay. This is how, the project started: planning, business blueprint, realization, final preparation. Project has gone live, and this is how. This is the project work, the green ones, and the brown ones are the future milestones. But these milestones have been carved actually in line with the tendency for the bulk rollout plan. The bulk rollout plan, they have validation, procurement exercise, engineering, design, software, networking, selection of vendor management, factory acceptance testing, system integration, operational acceptance test. This we have discussed yesterday in detail. So this is how you see. That's what I'm telling you. In sequence, we are going to understand how the project has been initiated and how the planning activity has started and how they have gone live actually to make sure that this particular project will not create any problem in the process of long run and in the process of mass rollout. So that is the whole thing actually. Philosophy is very important. So this is the project solution partnership. They have chosen Scion Technology UK for the AMI smart meters and communication systems. And they have integrated the whole meter into a horizon, what we call the pilot horizon. And the next bulk is to be decided by the electricity department as such. Okay. This is another case study, Kolkata. So, as CESC, Calcutta Electric Supply Company. So, this particular project also is a very important project as a pilot to make sure that how it ran into a real issue when they selected the communication, when they selected MDMS, when they selected the mass rollout plan, etc. for their distribution network. Okay, they have chosen communication based on cellular, PLC, mesh networking, others. In fact, we have to understand what is a mesh, what is actually all these things. We will discuss as we proceed further. They have chosen this. The matrix has been done, and they have selected based on what is needed on the robustness, stability, robustness, stability, longevity, sustained accuracy, in the sense sustained proving, etc., are the main parts with which they have drawn a scheme for the incorporation of the communication technology in the advanced metering infrastructure management. Okay. So vendors, one is selection of communication technology. Okay. Selection of communication vendor. One is the technology selection is very important in the pilot stage. What technology has been selected will prove a long way even in the mass rollout plan. So selection of communication vendor and selection of meter vendor. This is a very important proposal, as I yesterday discussed, and this will have an impact on the overall scenario of the of the healthiness of the project in the long run. Okay. So multiple make of meters communicating over the same communication network. Yesterday we were talking about the interoperability, particularly with regards to the operational characteristics, with regards to the management, with regards to the incorporation in detail, particularly minute planning is a very essential thing in the pilot and also in the mass rollout mechanism. Okay. In the pilots and also POC is proof of concept. A concept when you have, it has to be proved over pilot. See, why I am stressing all these things very potentially is, in fact, the failure rate, ample meter failure, communication failure, MDMS failure, HES failure, MDAS failure. Data, all these things are linked to what you select, what you intend to do, and how you can prove it over the pilot. Pilot is important. Yesterday, in fact, a question was also asked, and I have answered that question actually with regards to how the pilot should be and what the POC. POC, unless you do, if you have a concept, you must prove it. Prove it what? On what? Prove it along with the existing system and make sure that it works properly. Then only you go ahead. That is what it is. So they have one is Wi-Fi, RF mesh. This is from 865 to 867 megahertz. And then on RF mesh 2.4 gigahertz, PLC, okay, and GPRS. So this is what I yesterday I wanted to make sure that you also, when you want to make a pilot study, you must incorporate first what you have thought in your mind to make sure that it works without any problem, any issue, and take the positive points of the pilot to make sure that the pilot is incorporated in the main project running. So this is once again I would like to stress upon it. Okay. Here, the technology is PLC. What has been observed and what is best suited is given here. It works through our own network, highly dependent upon quality of LT network, noise interference. Okay. It is best suited for cluster meters, like apartments, multi-storied building. Okay. Cellular is suited. What they have observed is scattered deployment. That means distributed deployment. And here the manageability is difficult because of the distance actually. Okay. And there is no SLA based services from the service. Okay. Department. Okay. The scattered deployment here is okay. That is very important. Scattered deployment. Network coverage is good at every nook and corner. Wi-Fi security is a big concern because here the security means there will be a lot of attempts to make an attack, a cyber attack, which we will discuss in the evening. Okay, afternoon. RF mesh networking is important here. The networking 865 to 867 megahertz was selected actually. It is the scalability, self healing, auto reconfiguration, lesser number of network devices. Okay. So mass rollout of smart meter is one of the most important thing which is suitable for this application. Distribution, and here the DA and home automation and future smart city application. So these are how they made a beautiful matrix on the technology, observation, suitability, and they have chosen what is really required for the pilot. Aggressive and strategic approach. This is approach how they have made. In fact, consumer awareness through agencies, okay, sharing benefits, involvement of people, representatives, that is taking into confidence the consumers also. Installation of non-smart check meters at selected points to make sure that meter accuracy, meter performance, and also the essentiality of the meter is not diluted when the new meter is installed. So this is a very important message that will carry a long way. Okay. So here protocol management is also important because they are taking into account the public review, that is the agencies. Okay, the public is also very important to make sure that how essential the project is, what they are looking for, how it is arrived at, and what will be the process with involvement. The meters of different makes were employed: multi application communication canopy, RF mesh, backhaul, OFC, this is the fiber, cellular, secondary. Okay, and backend software is HES, or we call MDAS, and data analytics. Yesterday we talked about the big data analytics. Okay, the same thing is incorporated here. And here this is how the head end system and meters are integrated on the networking system. As we have seen, the RF mesh frequency is 865 to 857. Okay, 857 to 865. And they have used FTTH. This is fiber technology through home. FTTH communication. This is fiber to home, actually they call. RF mesh. Okay, same thing. Meter with the network interface card, that is actually to make sure that it is communicated properly. And this is the device for communication. Okay, this is how the project is finalized based on the pilot. Okay, so consumer premises, they have 7,500 meters installed, different makes. In street lights, 4 particular installations were selected, and daily red success is around 99.5%. So this is the project which I thought I should be in a position to explain to you in detail. Now we will see the engagement, consumer engagement, and policy regulation for the advanced metering infrastructure. Okay, the need for smart grid regulation, what is this actually? Overview. Okay, the regulatory decision drive the overall smart grid business through an approval of smart grid investment, recovery of these investment through different cycles, different modes. Okay, provision of the incentive and penalty to promote adoption of such solution by the utility management system, the deployment at the consumer end, and protection of consumer interest, and ensuring the value delivery. This is the main thing for the regulatory aspect. What are all the main constraints or main thing which will decide the regulatory? Number one, new resources and player. Okay, new technology. Okay, new standards. Okay, new products. Okay, cyber security threat, which was not there earlier, it has erupted as a new born thing. Changing investment scenario. Okay, this is very important actually, where the value system. Okay, technology. Okay, and then also a long time for realizing the benefits. These are all the main things which will have a total infrastructural management on the new regulatory aspects. Okay, what are the new resources? Okay, for example, distributed, consumer owned, demand side, and third party providers. Okay, new technology, because the technology we are talking here the AMI is a new technology, metering is a new technology, smart metering especially, vehicle management, electrical vehicle, energy storage option. These are all the new things which will have an impact on the regulatory mechanism. Okay, standards like the technologies and interoperability. Interoperability yesterday we discussed actually. Okay, so these are all the need for smart grid regulation. Okay, fine. So need for smart grid regulation, once again, from the consumer angle, supplier angle, operator angle, wholesale market. Okay, this is how we know transition of rules and actors in prosumer based power system. Prosumer is one who produces and acts as a consumer. Pro is producer, okay, and then consumer is consumer, right? Consumer who consumes. Producer is one who produces it, because the solar sun energy management, wind energy management, they're all prosumers today. They produce, they use it. Okay, fine. And this is the transition rule. And then today, prosumer, community, ESCO, and CVVP. This ESCO is nothing but energy service company, and CVPP is very important. That is commercial virtual power plant. Okay, and then it goes to TVPP. TVPP is nothing but your technical virtual power plant, which will have an asset management, an aggregator, an operation parameter, etc. And then it goes to the grid operator, wholesale market. This is how we know today the management of the grid regulation is coming into picture when we talk of the today's management, and when we talk of tomorrow's management. So this is how we know the tomorrow's management. This is how we know the today's management. And the whole thing will take into a particular shape with regards to what we call as a grid regulatory management. This is very important, from the point of the managing the new rules, the new regulation for the advanced metering infrastructure. What is the role of regulators? Okay. See, smart grids cannot evolve without dynamic regulation. That is known as enablers. Okay. Regulator will be a facilitator to smart grids business. That is, they are known as the catalyst who will promote the activity. Okay. Distribution company need to demonstrate clear positive benefit to the consumer, like business case. Fine. Regulators more than ever need to protect the interest of the consumers, like tariff shock. Avoid tariff shock. Today you announce something, immediately you withdraw and then take a new thing. The regulator plays a major role here. Okay. And then they must understand the consumers behavioral pattern psychologically, and to make sure that it will not create a ruffle in the society. And data and privacy protection is also equally important. Okay. Okay. So here the delivery policy, like approval investment, recovery through tariff management, providing the incentives, promoting the end use. So this is how we know the regulator technology, particularly the smart grid role of regulator, is coming into picture in the understanding the mechanism with which the whole activity shall happen. So this is the key regulatory framework. Number one is investment, design. How do you design the tariff? Standards, safety, customer engagement. Okay, this is a very important subject, particularly the management of customer. Smart grid cell and nodal officers. This is very important. So model smart grid regulations were issued by Forum of Regulators, FOR they call, in 2015 August. So from the investment angle, review of approval, recovery of cost, role of smart grid, consultation, evaluation, okay, implementation plan in the tariff design, process of tariff, from the safety angle, product standard, system standard, performance standard, network standard, customer data standard, protection standard. This is safety standard, which plays a major role in understanding the regulatory aspect. And in AMI installation, smart grid installation, smart meter installation, regulatory will play a major important role to assess various factors involved in the customer engagement, safety standard incorporation, design of tariff incorporation, investment incorporation. This is how the key regulatory framework is coming into picture. The consumer engagement policy is a very important factor in the distribution sector. So the policies are amended from time to time and new policies are framed. So smart meters will be the main interface between the utility and consumer. So migration of technology based on app for prepaid metering and billing system application. Okay. Adoption to the new system at consumer's end. New system at the consumer management. So smart metering system is not working properly. The end user, that is the consumer, is going to face a major challenge in the same. So we will discuss this, in a very important fact, particularly in a in a fashion which is really important to integrate the AMI with the component management system. So that is how the consumer is to be taken into confidence before a trial is made, before a pilot is made, before the project is introduced, before the mass rollout is done, because this is a very important factor, from the point of engagement. So in prepaid smart metering system, some complexities may appear in the form of temporary connection, temporary disconnection, payment methodology. Okay, so consumer engagement and acceptance is a very, very critical factor, determining factor for rollout of the metering mechanism. So consumer awareness and also engagement of campaigns, which indicates advantages of smart metering philosophy as a whole. So appropriate advice, information is important from the main angle of billing, social media, campaigning, call center. You can say make some videos, show how they are doing actually the activity, how it is being driven through. Very important. So we will now study mainly the process option for the meter reading, how it is done as a very important technology exercise. So the meter reading. So basic meters, which record the units of energy. Okay. The second stage is AMR. Yesterday we discussed about it, AMR in detail, how it is done. All the meters are read via handheld unit, a digital assistant, right? Or to a vehicle, driven through a vehicle, etc. AMI is the cutting edge technology we call, or the leapfrog technology. Cutting edge, leapfrog, fine. The meter readings are read regularly, say every 15 minutes remotely, and the data is logged on a central server where it can be used for billing as well as supporting the DR. Okay, in the real time of what we call megawatt generation. Okay, this is a very important. Fine, fine. So fine, the demand response plays a major role here actually. Okay, the process option for billing and payment is a commercial billing payment mechanism. Okay, physically visit the distribution company and pay the bill at a cash counter. So I think most of the villages even today is being driven through this exercise. Next, the consumer can log into the Discom secure website, pay the current bill, view the past few months bills. This is history is also available. I think this is second generation. This is also being driven through. Most of the towns, cities, they follow this. Consumer who can view and pay the bill online using various secure payment gateways. Okay. Today, probably lot of things like Google Pay, Phone Pay, and so many Beam Pay. So all these things are coming up. The consumer can choose the billing cycle as per weekly, monthly, or bi-monthly as per his convenience. So the consumer can log in, generate bill, and pay. So this is actually the next generation philosophy. In fact, the prepaid payment of bill with the meter is equipped with the remote disconnection, connection switch based on the amount of balance available. So tariff can be either TOU or critical peak pricing based. Okay. So we have to now understand what is really a DSM and what is actually a DR. So DR, as you know, is the demand response, is the term used, for programs designed to encourage end users to make short-time reduction in energy demand in response to a price signal from the electricity hourly market. Okay. The electricity hourly market is a new concept today. It is like a stock market. Electricity price will change from time. Okay. Or a trigger initiated by the electricity grid operator. Okay. This is very important. So typically, DR actions would be in the range of 1 to 4 hours and include turning off demand banks, lighting, adjusting, the HVAC, that is, the air conditioning mechanism, etc. Okay, heating and ventilating, shutting down a portion of manufacturing process. That means, cut off the supply, which is very, very heavy for the peak load system. Alternatively, on-site generation can be used to displace load drawn from the electricity power grid. On-site generation means it is a distribution generation. You can either adopt it on full scale or semi scale. So the demand side management is a program which encourages the end user to be very precise on energy efficient operation. So the DSM measures can include like what? Lighting retrofit, building automation, upgrade, recommissioning, and incorporation of variable frequency drives. Use DSM program to help to focus attention to reduce the cost of the demand charge on electricity bill, which can range from small amount to very high in kilowatt hours. Okay, so this is what it is. This is DSM. This is DR. We use this potentially in AMI, in our AMI management. Okay, so this is the process option for DR. Demand response. How it is? In fact, first, no DR. Next, basic DR is implemented with utility announcing the price during the peak hours and off peak hours. DR is automated, third stage, and the smart meter at the customer premises receives the price signal and accordingly controls the home appliances. Fine. More advanced version of DR is implemented. That is, we call advanced version of DR, where the effect of shifting of load on prices is also considered, and overall optimization. Shifting of load is very, very important from peak to off peak. Okay. Full-fledged DR. This is where, what we call the full-fledged DR, which is a system for entire distribution grid integrated into either SCADA or DMS system to identify the most optimal source of DR to use the stable, reliable operation of the grid mechanism. So this is how, the process. We have to take people, process into confidence. This is the process which, the AMI is being initiated for our technical discussion. Demand side management. First, no demand side management. Next, demand side management on day ahead forecasting. Utility signs agreement with user for remote control. That is, cut off supply during peak period. Okay. And then certain load by utility meters. Okay. Connection, disconnection procedure. Okay. Superseding the load curtailment. Okay. Next, utility control DSM. That is superseding the load curtailment by user allowed. Next, integration of DSM and operation of the distribution generation. So this is a final step is very important. How the integration of DSM to the DG is taking place. DG is distribution generation. That is incorporation of the solar, the wind, the biomass, etc. into the main grid stream to make the grid interactive. Okay, fine. Process options for connection. So this is how, the consumer physically goes to the designed utility. Consumer goes to any of the utilities office physically to apply for connection. Consumer can online apply. Consumer can submit application. Consumer can select utility for where he wants to connect. Actually, this is what, the process operation. And the customer care center. First of all, there is no customer care center. Next, a call center with to take care of the complaints. A call center is linked to the central consumer database. Okay. The workforce management system is also integrated. Next, the geographical information system is also integrated. This is, the GIS to the call center workforce management. That means the whole thing is integrated. When you are booking an Uber, what it will ask for location, on the GIS scheme. Same thing here actually, the geographical scheme, where the operator, they will ensure the customer care operator to know about the outage even before the customer calls, and it is able to mention when the supply can be restored. So this is a very important process. And the process options for the tariff scheme, this is either TOU, critical pre-pricing. Okay. First, a simple fixed flat tariff. Next, the consumption level is divided into slabs. Next, the basic time of use. Next, along with the time of use, critical pricing. Next, TOU, critical pricing, and the real-time management of the data. How the whole process will take place is a very important activity. Okay. And storage, in the storage mechanism, this is also very important in the distribution management, particularly with regards to what we are seeking today. Okay. Consumer does it, customer has inverter and battery, the consumer has excess capacity inverter, the consumer can enter into contract, the consumer also adds local renewable generation to the inverter management system, battery management system, to achieve self-sufficiency and to have limited exchange with the grid. So these are all the main important factors which will determine what needs to be strengthened, what needs to be done for different operations, taking into account the customer into confidence and also taking into account the pilot into confidence before launching the new scheme of operation. So this is how the possible components of the tariff structure, components of the tariff. For example, generation cost, transmission cost, service cost, UI. Here this is a change of frequency, etc. Reactive power, unscheduled. Okay, subsidy, TOU, CPP, power supply quality, TOD, time of the day. This is actually time of the day, voltage level, sanctioned load, frequency, penalties, harmonic injection. Oh, these are all things which will have a total structure for the component. A regulator should have a knowledge to make sure that this is in line with what they think called the technology evolution exercise. Okay, very fine. So we will now study an aspect related to communication technology, and I think probably something has already been discussed, but something which is very relevant for the AMI application, I would like to discuss today, and to make sure that this will have an impact on the overall technology application upgradation exercise for the electric utility. So here, the technology, cellular, wireless, hardline, BPL and PLC, broadband over power line, and the power line communication. Okay. Benefit, geography, no additional infrastructure, broadband coverage, rapid deployment in the cellular. The challenge is high variable expenditure. Next, wireless technology. It is the benefit is engineered according to the requirement. The main challenge is infrastructure cost. Achieving coverage. Coverage is very important. Geography. Okay. Hardline. Hardline is actually the proven technology. Today we are seeing that hardline technology all over the country. It is able to configure size. Okay. What are the main challenge? Fixed expenditure, high, difficult to manage individual circuit, reliance, and also the carrier infrastructure. BPL. This is utilizes the existing infrastructure. Okay. The broadband promise large theoretical geographic coverage. This is theoretical, but challenge frequency interference is very important. Signal to noise ratio is high, high price point, and limited success in the field trial. So this is how we know the benefit and cost challenge is to be taken into account in the matrix. What you select, what you need, what you intend, they are all certain things which will have an impact actually. In fact, when you say that this particular thing is not working today, you must make sure that it works today, and then tomorrow you should not have any problem. So most deployments rely on multiple technology to achieve a full coverage cost effective solution. Okay, this is what it is. So, in fact, we have to now understand what is LoRa, because LoRa technology is being adopted today all over the world and also at the national level. LoRa is nothing but a wireless technology for low power. LoRa means actually they call long range. Okay, low power wide area network. That is LPWAN they call low power wide area network, which is essential for the Internet of Things and M2M application, machine to machine. Okay, so the technology offers a very high penetration, very low bandwidth, low energy, wide area spectrum, and data security is very high. And it is gaining significant traction in IoT network, being deployed by the wireless network operator and governmental agencies. It has its own segment operating away from the cellular network. So here you have you can compare it actually. This is a smiley, this is a reverse of smiley, and this is the penetration, local area, okay, and then this is LPWAN, low power wide area Internet of Things, okay, cellular network. This is a traditional machine to machine configuration. So you can see here percentage, well established, low power consumption, existing coverage, high data rate, okay. Here the non-smiley is battery, okay, provisioning network cost and dependency, high data rate, okay, the autonomy total cost of ownership. So there are a lot of suppliers, for example, uh, the local area Wi-Fi, and then Bluetooth, LoRa they call, cellular technology, okay, 3G, 4G, and then we are stepping into even the next goal 5G also, okay. What are the salient features of LoRa technology? Number one, it is a long range, greater than cellular, deep indoor coverage. The star topology. We will see what is this topology means. So life of the battery, low power, automized, 10 to 20 years lifetime battery. Okay, greater than 10 versus cellular M2M, actually machine to machine configuration. Okay, multi-use, okay, capacity wise, talent wise, this is the talent wise, that is talent in the sense of who takes into lease in the whole matter, public networking philosophy, cost effectiveness, optimization of cost, minimal infrastructure, low cost, and then open software system. Okay, these are all the main things which you're covering. Okay, LoRa, that is long range, is a spread spectrum modulation technique which is derived from chirp spread spectrum, that is CSS technology, we call. Semtex LoRa devices and wireless radio frequency. This is one of the makes actually, is a long range, low power, wireless platform that has become the de facto technology for IoT, the Internet of Things today. LoRa is a wireless technology that offers a long range, low power, secured data transmission, M2M, and IoT application. Here, you can see I have made a small sort of a table to make sure what is this, who is the governing body, which is the standard. Okay, this is actually 801.15 4G spectrum. Okay, frequency ISM. ISM is industrial scientific medicine, which doesn't need licensing, 868 to 915 megahertz. Range, data rate, modulation, and then you can see the security, 32-bit CRC. CRC is the cyclic redundancy check in the computational network mechanism. Okay, so this is what it is. Some small case studies, international, particularly what are the communication they have employed in the AMI. For example, we will see first basically understand the communication for AMI. Okay, this is the smart meter. Okay, on the real-time mechanism, remote connection disconnection switching mechanism. It will have a cry out alarm. Okay, it cries when there is an event actually, like theft or loss reduction. Okay, remote management, it configures on the remote configuration, on the firmware upgradation exercise. So this is the requirement. In fact, these requirements have been taken into account for the study, like the grid application, like distribution automation, substation monitoring, AMI, demand response. You can see here distribution automation, the bandwidth, okay, low to medium, substation, low to high, AMI, low to medium, demand response, low to medium, And you can see the bandwidth is also given 9.6 to 100 kbps, 9.6 kbps to 1 mbps in the substation monitoring. In the AMI, 9.6 to 100 kbps. Demand response 9.6 to 100 kbps. Latency, here you can see what is the actually time lag here. You can see 10 milliseconds to 100 milliseconds, 15 milliseconds to 1 second, 1 to 10 second, medium to loose here. Reliability, okay, here very important, very high, low, low, medium, okay, low to medium. Security, excellent security in all over. This is what we want to study in the mechanism with which the reliability of the communication system. Failure will be avoided if you if you choose a proper communication system in the smart metering philosophy, AMI philosophy, to make sure that the failure rate is minimal and the failure rate will not be there as such. Okay, next, architecture deployed by the Centerpoint Energy, Houston, USA. This is another early mover. They have used what we call mesh technology. The mesh technology here, the smart meters connected in mesh networking system. This is the DCU and gateway, and this will have a BPL communication. That is, the BPL is the brand or power line, the substation. This is the optical fiber, and then the utility data center. So this is how one of the case studies Houston, USA employed, and they made huge amount of meters they installed, and strictly they are following these norms without any problem. And the outcome of the project is excellent. Failure rate is very minimal, and then their stability is excellent, and they are making a good show, particularly with regards to the employment opportunity, particularly with regards to the stability opportunity here. This is NL Italy. They have incorporated around 25 million meters actually as it stands. Okay, and this is DCU smart meter is connected. This is the narrowband PLC. Okay, and then this is GPRS, and this is utility data center. So this is another scheme with which the communication mechanism is being driven through. But why I am giving you all these things is choose the optimal one, choose the best one to make sure the failure rate is very minimal at the when you take what we call the mass rollout programming. That is very important actually. Okay. So this is a typical AMI architecture with RF mesh as a last mile. Okay. This has emerged as a popular solution among utilities and many geography. For example, this is IHD in-home display. It is this is along with the smart meter. This is supplied, which will record or which will display the amount of energy, present energy cost, peak consumption, off peak consumption, etc. Okay, this is linked to Zigbee PLC, and then this is a smart meter connection RF mesh, DCU gateway, GPRS, utility data. So this is another case, international case. And emerging architecture for smart grid and smart city application, RF mesh canopy network is the latest trend. What is the canopy network? Canopy network is nothing but a network which is connected in mesh canopy. Oh, canopy here, the N is nothing but the node for any application. Okay, AMI, DA, street lighting, traffic signaling, controls, surveillance, etc. And then you go to the DCU. Here, this is DCU gateway. This is the fiber optics communication, utility data center. This is where the application of this entire thing has been managed. Communication architecture for next generation smart is known as IP metering. IP metering is based on the internet protocol. Okay, here we have the home. Okay, SCA is the smart appliances. Each appliance is smart, which is linked to smart meter on the communication network. Maybe Zigbee, maybe Z-Wave, whatever it is, or even PLC. Fine. So here, this is the cloud where it goes to the internet, smartphones, software applications of the consumer. And here you have the HES and MDM as part of the AMI tool. And this is how the data application driven through. So this is how the communication architecture for the next generation smart metering is being driven through. Okay. What are the 10 top IoT communication protocol in 2020 up to 2021 updated? This is taken from LinkedIn once again. Okay. And you can see here this cellular technology, and this is MQTT. Oh, this MQTT is nothing but message queue telemetry transport, actually, the concept which has been come very recently. Zigbee, Bluetooth, Wi-Fi, OPC UA. OPC UA is nothing but the unified architecture, open platform communication. Okay, and then NFC. So this is nothing but the near field technology. Sigfox. Sigfox is actually a French global network operator. Okay, LoRaWAN. So this is another WAN technology based on LoRa. So Z-Wave, these are all the main uh, communication protocols which can be addressed, for various. But what you choose, what you intend to do, and how you select is based on the pilot, based on system selection, based on the study what you make, and the results what you get. Actually, very important factor, which is essential for our application. I think requirement of the smart communication network. Number one, transmit and collect data. Number two, ensure the security of data. Number three, maintain, manage the communication network effectively and properly. Very important. That is, install management function, rapid recovery function, from failure to maintain healthy communication. Question was asked yesterday, and the answer is here actually. Okay. Continue running for a long time, selecting a communication system, construct, maintain at a low cost, optimal cost for the TCO, total cost of ownership. So this is how the requirement of the communication technology. This is a matrix made to distinguish between the Zigbee, Bluetooth, PLC on technology comparison, cost comparison, and data rate comparison, latency, etc. You can see here what you choose depends upon what you intend to do. Zigbee, Bluetooth, PLC. You can see cost, you can see the power, you can see the data rate, complexity, density, interoperability, ease of usage, latency, interference, security. So this is how the whole thing has been drawn to make sure what you select is important to the system, what you intend to do actually, right? So IEC BIS communication protocol layer from Calcitech Technology. If I taken this slide actually, this is a very notable information on the software and hardware. On the software, you have application layer, transport layer, network layer. The system specification is actually IS 15959. This is the TCP UDP, that is the transmission control protocol, and user datagram protocol. And then here the routing protocol, IPv6. This is nothing, internet protocol version 6, which is running today. And then here, of course, it's a hardware system, not linked actually, but the technology is important, like the cellular technology, RF technology, and the PLC. Okay, so this is how the interoperability standards, the vendor specific thing. And here we have IEEE 1901.2, a vendor specific PLC. So this is how the IEC BIS communication protocol layers have been defined and has been taken for the mass rollout program. So next, in another 5 minutes, we will study, integrated arrangement of advanced metering infrastructure. Very important from the point of what we understand actually, technology-wise. This is the architecture. Okay, home area network, consumer, where the GPRS and RF figuring is coming up. This is the data concentrator. Okay, and here the wide area network is being driven through, and this is nothing but your head-end system. This is the MDMS, where the billing, the OMS, the other systems are driven. So this is the architecture of a typical architectural plan for an AMS technology, which is being driven for the application of pilots, for the application of finalized management for the advanced metering infrastructure. Okay, integration is done, is very important actually. You can see this: meters, networking, head-end system, customer management, utility. The smartness comes from the entire system component and not just one or two components. Hence, it has to be seen, designed, implemented, keeping what? End-to-end system approach. and not the product approach. You should not look into the AMI as a product. You should look into AMI as a system, which I'm going to explain now. You can see first actually the smart meter. For example, what it does: data reading, data is transported, data is acquired, and then consumer engagement, data analytics. This will happen as a whole activity in the philosophy of the integration mechanism. Okay. This slide, these one or two slides are taken from Landis and Gale, the world famous meter and system manufacturer based in Switzerland. Okay. Next, advanced metering infrastructure. The meter conforms to the IEC 62056 and IS 16444. Next is communication. Communication, reliability, scalability, security, multiple application. That is very important. Head end system. Head end system acts as an acquisition system which stores data of smart meter. Okay. It should be decided based on the communication network, robustness, scalability, adaptability, acceptability, and also upgradation. Next is meter management, meter data management. So MDMS provides a utility-specific business logic to automate, streamline the complex billing and data analysis process. Very important. Consumer interface. Consumer interface is CI technology, particularly the smart metering system is a distributed intelligent system. Therefore, the requirement of CI is very, very critical, as all the alert related availability of power, critical pricing, dynamic pricing shall be made available on the CI platform. So next we will go to what we call the performance requirement. Performance requirement is done, basically to facilitate high, accurate, timely availability of data, alert mechanism in the AMI system. Okay. So this is how the AMI system components have been integrated into smart system philosophy. Okay. Designer's challenge. This is once again taken from Landis and Gale, where the energy management, okay, interval, accessibility, and then consumer application. They have been matrixed to make sure that you select what you want, you desire what you want. So the registering mechanism, the TOU capacity, the billing mechanism have been integrated into the metering system: single phase 2-wire, 3-phase 4-wire, 3-phase 4-wire, CT operated, PT operated, high tension metering mechanism. Okay. And then conformity to IS 16444, DLMS 15959. Okay. And then 14947 DLMS compliant metering schemes. So this is how the real-time smartness comes on the design philosophy of a smart AMI networking mechanism. Okay. So here, the development solution, network analysis. This is how, the deployment plan, how, you can mass roll out the AMI. Make a developmental solution, analyze the networking, E2E, that is, end-to-end validation testing, utility perspective management, operation and maintenance. All these things have been further discussed, which probably I have discussed yesterday also. And then probably the repeated ones, I will just remove it. And then we can go for the deployment scheme, like, how the deployment is done. Based on, number one is the data security, process re-engineering, skill enhancement, consumer engagement, regulatory support. In the data security, consumer data, meter data. In the process re-engineering, this is we call BPRE, business process re-engineering. Here, the identification of new process, changes in existing process, skill enhancement, existing team skill, induction of new team, consumer engagement, mobile application apps, other services, regulatory support, smart functionality, and incentivizing the consumer management as such. So successful deployment of utility management with IT team, procurement team, operational team, policy process. It is not possible by single individual. It has to be done with taking into account the various sub teams. For example, you have to have a telecommunication engineer with you, and you have to have a system IT engineer with you, and you have to have the data analytics engineer with you. So make sure that all these things are integrated into what we call a holistic approach solution. From the manufacturer angle, meter manufacturers take them to confidence. IT system providers, consumer and HES, deployment team, okay, and go to third party laboratory to make sure that it validates, it is tested in accordance with the system engineering protocols. So the smartness comes from the entire system component and not just one or two components. Hence, it has to be seen, designed, implemented, keeping the system approach. Very, very important, actually. Okay. So this is designing of an AMI solution, SCADA, OMS, ERP, postpaid billing, okay, and then unified prepayment vending mechanism, mobile app, web portal, GIS. We have here, SAP, the business system, and then here the MDMS, and then here the HES, and here you have the subsystems, the meters, okay, DCUs, etc. Of course, the NMS is nothing but your network management system, okay, and then TSP is nothing but your transient signal priority, which where we take into account the system engineering management, okay, and this is how the AMI solution is being arrived at. So this is the lightweight directory access protocol. This is being used, employed, for the fortune making companies, particularly with regards to the management of the data supporting services. Okay. Components, for example, meter, communication, readings, SAP, integrated together into what they call the business process. This is how the AMI components is being driven through. Okay. And this is how the exercise is being run either on pilot or on the mass running of the project. Okay. So how you can integrate AMI for the outage management? For example, this is the AMI. This is all meter. The gasp. Yesterday we discussed what is actually the gasp, particularly the last breath and also the first gap. We have discussed yesterday. The preprocessor, logic filter, useful gasp, advanced distribution system, outage management. This is ping from the operator and then it goes back. This is how the study is being cycled actually in the integration. So this solution leverages the known connectivity of the distribution system fed back from the ADMS, okay, to enable intelligent filtering and control over the AMI gasp information. So this approach allowed international project team to filter out unwanted signals and fully control the way AMI information flows into the OMS, that is outage management system. Outage management system is one of the most important factors to determine the healthiness of a particular feeder, a particular network, a particular sequencing of the distribution and generating company. So almost I think we have come to the end of the presentation. So smart policy. Before a decision is made on smart grid implementation, AMI implementation, a supportive regulatory framework needs to be built and right governmental policies must be in place. So the section that follows describe key areas in which the policy plays a defining precise role actually. Okay. Security plays a major role. The policies to be designed for the new smart grid ecosystem, it must make sure that the consumer management is given a big thrust actually. The policies must be the cyber justice, security controls, providers, which ensures robustness and flexibility of the system. So at this point, utilities need to analyze their current state of technology and implement new technology, new process accordingly with regulatory practices. So existing system must be made smart grid ready, which requires not only infrastructural upgrade, but changes in current practices and regulatory framework. So the ease of stress on today's infrastructure, today's renewable and microgrids, peak load reduction measures need to be added, need to be integrated on a holistic platform. It is given the enormous scale of implementation in India, which take away from pilots. Implementation need to be analyzed thoroughly to avoid pitfalls, to benefit from the experience gained over the period of time. All activities are to be holistically, synergetically developed to make a unified power ecosystem. So you know that electricity demand is expected to nearly double by 2030, but high aggregate technical and commercial losses mar the sector. So the reliance on postal service in sending bills to customers, delayed payment, collecting tariff, and accessible geographical location has prompted to need to look into an alternative. So ATC losses are the major contributors to overall power losses in the sector. As a result, distribution utilities lose almost 72 paisa per unit of electricity they purchase. Union Ministry, Power of Ministry added. The country aims to cut ATC losses to under 12% by 2022 and below 10% by 2027. So the losses are currently pegged to 20%. India is also transforming its energy mix by installing more non-fossil fuel-based energy generation technology. Small grids are entrusted to both integrate renewable energy and reduce the ATC losses. AMI is the best option, which is digitally augmented electricity infrastructure, which automate and manage the increasing intricacies on the power supply as well as the demand side. Thank you for your patient listening. And any questions? In case of time management, time is overrunning, you can write down your question and you can post your question later on. No problem. I will answer them. Okay. Thank you for your patient listening. I am happy that you could listen to the presentation. Probably you enjoyed it, and then you can not only make sure that you take back what you really require for the mass rollout of program. Thank you so much. Very nice.